We begin our unit on exponentials with graphing an exponential parent function. Let's take the graph of y equals 2 to the x power. When x is 0, 2 to the 0 power is equal to 1. When x is 1, 2 to the first power is equal to 2. When x is 2, 2 to the second power is equal to 4. And when x is 3, 2 to the third power is equal to 8. So let's graph this. This is the graph of the function y equals 2 to the x. This graph gets close to the line y equals 0. Y equals 0 is the asymptote of the function. The domain of this function is all real numbers. If we were to pick a point, as far left as this graph would go, it would be somewhere out negative infinity, positive infinity, because that's in the second quadrant. In the first quadrant, if I was to pick a point out in infinity somewhere, it would be positive infinity and also positive infinity. So as the x values go from negative infinity to positive infinity, that's all real numbers. The range is all the numbers greater than 0 because it's above the asymptote at y equals 0. And the asymptote is y equals 0. So this is the graph of the exponential parent function. The points in the table are your key points, and you can graph an exponential of any base the same way. So using what we've learned from previously studied functions, what effect do you think each of the following will have on the graph of the parent function? So you try writing down what you think will happen. So in number 1, we have a vertical stretch by 2. In number 2, we move left 3 units. Number 3, we move right 3 units. Number 4, we move up 1 unit. And number 5, this is a reflection, and we move down 5 units. Since we're using 2 to the x as our parent function, remember that the negative sign is a reflection over the x-axis. The A is a stretch or shrink. The H is a right or left movement, and it's opposite of the way we think. And K is our up and down movement. Also remember that if there's a number, a negative sign, in front of the X, then it's a reflection over the Y. Same information, different parent function. Now let's graph a couple of exponential functions. To start with, we know that this is a vertical stretch by 2. This function is also moving up 1. Now remember, we're talking about our asymptote moving up 1. HK, since there's no H in here with X, will be 0, 1. So I'm going to go out 0, up 1, and this is the new asymptote. 0, up 1, this is the new starting place. Let's take the old key points, and let's find our new key points. In the red here, you can see that nothing is being multiplied to x. It's still a 1x, so x does not change, and all these values stay the same. In purple, there is a 2 being multiplied to the base 2 to the x. So I want to multiply all the y's by 2. So this is 2 times 1 is 2, 4, 2 times 4 is 8, and 2 times 8 is 16. So this is what I want to graph. So starting from the new HK, which is right here, we're going to go out 0, so to the right 0, because all of this is right or left movement, and this is up or down movement. So we're going to go right 0 and up 2. We're going to go right 1 and up 4, right 2 from here, 1, 2, and up 8. So this is a graph that goes like this. The domain of this graph is all real numbers, The range is above y equals 1, so it's y is greater than 1. And the asymptote is y equals to 1. So this is the graph to function number 1. Let's look at number 2. The negative sign tells me I have a reflection. The x plus 3 tells me I'm moving left 3 units. And the negative 5 tells us we're moving down 5. HK in this graph would be negative 3, negative 5. So 1, 2, 3, down 5. So the new asymptote is at negative 5. And HK is negative 3, down 5. So the new starting point is right here on the asymptote. This right here is where the asymptote lies. The asymptote is at y equals negative 5. Now let's find our new key points so that we can graph. Notice that the only thing I am multiplying by the base, which is 2, is a negative 1 for the y. But for the x value, there's nothing being multiplied to x, so the x stays the same. So I'm going to rewrite all the x values, and all the y values we will multiply by a negative. Now let's graph. Starting from the new starting point right here, we're going to go to the right 0 and down 1. So starting from the new starting point, right 1, down 2. From the new starting point, right 2, down 8, and that's kind of off the graph. So this is a graph that's going to curve in this direction. The domain is all real numbers. Since the graph picture is below the asymptote, this is y is less than negative 5. And the asymptote is y equals negative 5. So this is the graph of function number 2. In function number 3, notice that our base now changes to a 10. I still have movement to the left 2 units. And we're going down 1 for the asymptote. HK is going to be negative 2, negative 1. So negative 2 down negative 1 is the HK, is the new starting point of the graph. And the asymptote is at y equals negative 1, because negative 1 tells me that the asymptote is down 1 unit. The old key values, well, that's going to change because now our base is 10. So let's look at the parent function if it was 10 to the x power. If I put in a 0 for x, 10 to the 0 power is 1. If I put in a 1 for x, 10 to the first power is 10. These would be the key points. If I put in 10 to the second power, I would be at 100, so that's not going to fit on the graph. Now let's look at some new points. Is there anything being multiplied to the 10? No, so the y values stay the same. Now let's look at the x. Again, there is nothing being multiplied in front of the x, so the x values will also stay the same. Now let's graph these points. From here, when I go out 0, I go up 1, so I'm starting from here. For the next point, I'm going to go to the right 1 and up 10. And this is the graph of the function. The domain is all real numbers. The range, since the picture in the graph is above y equals negative 1, the range is greater than negative 1. And the asymptote is y equals negative 1. Let's look at e to the x minus 1 power. Well, this is a natural number, and its parent function is y equals e to the x. And it is just like pi in that it's a non-repeating number that goes on and on and on. And e is equal to, let's approximate it to be 2.7, like we do pi with 3.14. So my old values, when x is 0, any number to the 0 power is still 1. And when x is 1, well, e to the first power is 2.7. Now let's figure out what's happening. There is nothing being multiplied to e. The old y values would stay the same. And there's nothing being multiplied to x here. So the x values would also stay the same. Now let's find hk. H is 1 and k is negative 2. So we go to the right 1 and down 2. The new asymptote is at y equals negative 2. Let's finish graphing. The domain of this function is all real numbers, and the range, since the graph, the picture, is above the asymptote, its y is greater than negative 2. Now let's write some equations. On the first one, let's start with y equals 10 to the x. This says shift left 3 units. So that means I'm going to have 10 to the x plus 3, because remember this is opposite, and up 2. So this would be 10 to the x plus 2. So let's write this equation. Y equals 10 to the x plus 3 plus 2. For the next equation, we're going to start with y equals e to the x. Reflect across the x-axis. That's going to be negative e to the x. Stretch by a factor of 2. So that's going to be 2 times e to the x, because we're stretching means we're multiplying e to the x by something in front. Shift right 4. So this would be e to the x minus 4, because if we're shifting right or left, it's the opposite. And down 3. E to the x minus 3. So if I was to write this equation, it would be y equals negative, I'm going to put all this stuff together, 2 times e to the x minus 4 minus 3. Number 3. We're going to reflect across the x-axis. Again, that's going to be, we're going to start with 2 to the x, so this is negative 2 to the x. We're going to shift right 6, so that's going to be 2 to the x minus 6 power. So let's put this together, negative 2 to the x minus 6. Let's look at number 4. Again, start with 2 to the x. We're going to shift left 1 unit. So this is 2 to the x plus 1. Down 7 would be 2 to the x minus 7. And shrink by a factor of 5. Since we're stretching and shrinking, that would mean we would be multiplying to the base. So let's put this together. Y equals 0.5 times 2 to the x plus 1 minus 7. Last one. Start with y equals 2 to the x. Reflect across the x-axis. So this is going to be negative 2 to the x, because when we're reflecting across the x, this gets multiplied in front. Stretch by a factor of 5. So this is 5 times 2 to the x. So let's put this together. Y equals negative 5 times 2 to the x. Okay, let's look at the last two. Write the equation of each graph pictured below. So for purposes of this unit, y equals 2 to the x is our parent function, so we're going to use that. First, let's find our asymptote. Our asymptote is right here at y equals 0. So that means that whatever I have, I'm going to be adding upper 0 down. We're going to use 2 to the x, and let's see what happens. Did I move? Did I reflect it? No. Looks like the starting point would have been here, because remember the asymptote did not move up or down, so that means it's still 1 unit away from the start of the graph. So that means the 1 unit away is right here. So this graph actually went from here 3 units to the left. So this is going to be y equals 2 to the x plus 3. In the second problem, I have a reflection. Let's figure out where that asymptote is. And it's right at y equals 0. Notice that it did not move up or down, so that means that my point's going to be one above it, or one below it, and in this case it's one below, so it's right here. So this graph did not change. It just reflected -2 to the x power. And that takes care of graphing exponential functions.